Thing before I start, all my anti-heckling jokes are definitely going to break the code of conduct, so hold it for the end. I'm Brandon Faulls. I'm the newly minted, as of a week ago, head of platform engineering at Babylon Health. I'm joined by Eirik Albrigtsen. It's the classic innovator and imposter. You guys can work out during the talk which one is which. Mark Twain said that, you know, if I had more time, I would have written a shorter letter. We found out we were going to be doing this talk end of last week, so there's a lot of dense stuff in here, and we're going to be going fast. So tray tables and seats in the upright positions, and buckle up. So what do Babylon Health do? We are a healthcare provider, fully modern healthcare provider. We believe in putting healthcare in the hands of everybody on Earth. That means that we are trying to make it affordable and accessible. We're operating in the UK as in a partnership with the NHS. We also have private healthcare within that, and we also operate internationally via partnerships with various national healthcare systems, insurers, etc. Where we also operate in Rwanda. Where in partnership with the Gates Foundation, we provide healthcare to a large number of the population with a very small medical community due to the diminished medical community due to the genocide. So we're really helping the Rwandan communities leverage up what medical care that they have to a wide amount of the populace. The services that includes are a chatbot-driven, AI-led interaction that allows you to understand your current conditions, help triage anything that you're experiencing with regards to your health. We have doctor services 24/7, and that includes anything from a short time to book telemedicine interaction, much like Skype, so you've got interaction via your mobile, and fast access to doctors within the London area and soon to be wider with actual healthcare clinics that allow you to get quicker access to your GP via that. Now, and then of course, we've just recently launched something called Health Check, which is a kind of lifestyle and health assessment that again is done via the app that lets you understand your current conditions and how your lifestyle has impact on that. The cool benefit of a lot of this is that we give you access to the data that we have about you via the app. So you're able to review the session notes that you had in discussing with the GP. You can re-watch the sessions that you've had as you've been describing the interaction with the doctor, and it gives you a little bit more control over kind of what your health experience is. It's been enormously successful so far. Obviously, the promise of what you can do in terms of providing healthcare for a population that is aging quickly, that needs to be able to give healthcare to more people with the same amount of resources. Obviously, that makes it appealing to insurers, national healthcare companies, etc. So it means that we operate in the UK, we operate in Rwanda, as I've said, but we're rapidly expanding around the globe. That means that we are in mainland China with a large internet conglomerate. We're in Southeast Asia via an insurer, and likewise we're expanding into North America via an insurance partnership. That means that we have a tremendous need to do everything we do has got to prepare for stupendous amounts of scale. And when we talk about scale, we're all accustomed to these kind of natural curves of organic growth, right? We're used to seeing that we've got a service that succeeds, and therefore we're in a region where hopefully we get a hockey stick curve of numbers of users over time, you know, usage of our systems and the scaling of those, perhaps elastically, over the course of years, and with that peak right at the end of big effort. Because that's naturally a kind of business to consumer curve. Because we're operating business to business, when we onboard with a new national health service or an insurer, we're getting instant access to a stupendous amount of new users. So it means that, yes, we've got to scale for more traffic and more growth, but it means that we're getting that in a stair-step fashion, right? Every new customer that we bring on and every new region that we enter into means we've got to instantly provide for all of that at any one time. That means that we're really having to think about, because of national boundaries, because of the way that information around healthcare is necessarily private and sensitive, oftentimes there's regulatory requirement for us to only keep that data within the region. So Canada is a perfect example of information about citizens needs to remain within the bounds of Canada. Quite reasonably, that feels like a natural protection that is in place, but it means that we need to then operate in those regions. And it means that our stacks need to remain there in order to protect that integrity of the user's data. So that kind of asks something very specific about how we deploy infrastructure and how we operate it. And really what we're asking is that our unit of deployment has gone from a microservice, and I'll talk about what services are there. We go from a microservice or a suite of services to the unit of deployment being an entire cluster. And when I say a cluster, I mean Kubernetes, persistence layers, the entire ball of wax that actually gets deployed in one region versus another. And that asks a lot about the number of people that we have on the team, and it asks that we constantly prepare for scale. And likewise, it really means that our tooling that operates within one cluster has to be able to operate consistently across that universal deployment plane, right? Kubernetes lets us think about all of our microservices above Kubernetes in the same way no matter where we're deployed, and we can abstract away all those regional differences where, say for instance in the UK, yes, we're likely to choose something like AWS for Rwanda. That's not accessible to us. We're on tin in those areas, and we have to prepare globally that some of those regions are going to be accessible via AWS, maybe Alibaba, some of them might be on tin. So we're thinking about that as a universal plane, but our tooling has to leverage so that it operates globally and consistently and supports our users, meaning really our platform users are our engineering partners, has to support them the same everywhere. So a year ago, our colleague Jeremy Vallet came and presented a kind of hybrid model, not dissimilar to what Gary was describing, of containers on instances, maybe scheduled via systemd initially, large amounts of density, but kind of hand-rolled in with configuration management. We were solving some of those problems, and when I say we, make no mistakes, this is a strong team that I've only recently joined, so the credit belongs there. But doing a lot of that with Kong as our API gateway, and to do some of that interaction between services. We're on a kind of evolution, much like many people. You know, we begin like anyone when we were at the startup phase rather than the scale-up phase. We had a monolith like anybody else does, and I would argue that's a good place for any new business to start. Discover your patterns before you break them out. We then moved to the containerized monolith, so something of that hybrid approach, natural approach. Let's get it to something where it's going to be scheduler ready at an eventual date, but it's a good place to go. We then go into Kubernetes land, which is a more recent expansion for us. It's distributed monolith, right? Like we've got lots of microservices that are more or less loosely or tightly coupled depending on the weather. Anyway, the distributed monolith, and then we're getting into that notion that I've just talked about of many multiple clusters behaving the same way. You're getting into more distributed monoliths, and eventually it begins to look, with all of the things in it, looks a bit more like a cloud. And the time frame for this is pretty hectic, right? We're talking about growing the business, but we're also talking about the growth of the team. When I joined, we were 300 people. We're now 500 people. That means that we've got to allow our engineers who are onboarding quickly to have a really, really easy experience of deploying and building and supporting their services as quickly as possible. It's a colossal demand for business, so we have to prepare for that scale. Things that come up at the regional level don't always apply. You know, object storage, we take S3 for granted, but object storage in sub-Saharan Africa is an entirely different ball of wax. We want that universal deployment surface, and we want something we can reason about for our services. And we need tools that help us kind of do outsized impact with the least amount of interaction and the most amount of abstraction to kind of lighten people's cognitive load about how their services will run, how they'll get deployed, and make those tools predominantly an expressive form of getting those things from conception to production. So I'm going to hand to Eirik, who's going to describe kind of one of those key tools in our quiver and how that applies to those patterns.
All right. Great. Thank you very much. I am Eirik. I'm on the platform engineering team at Babylon Health. Is this close enough? And I'm going to take you back a little bit first to describe how our old microservice deployment model was. Effectively, we had a couple of instances of the server, pictured here on the right in form of pumpkins. And our deployment model was take them out of the load balancer, not pictured, and our single engineer was doing the surgery with Chef. And obviously this works very fine. You have a blue-green deployment system by taking them out, and this scales completely fine. You just add more instances of the server. However, there's the obvious problem here that there's only one guy that can actually do this deployment, and our unit of server had all our microservices on it. So that's obviously one of the big rationales we wanted before moving to Kubernetes. We want to break up that silo and have people managing their deployments themselves.
Can you get a bit closer to the mic?
Sure, sorry. So I'm talking a little bit about how we started moving to Kubernetes, because if your ops team looks like this, then your ops team is going to be the guys doing the actual migration of the services. And so what they want to do is they want to beat the dead horse and actually create this first folder of YAML from what you've got. And they're going to be the ones to try and find the patterns in that YAML, because there's multiple ways of doing things on Kubernetes to achieve mostly the similar results. And you kind of want to minimize the stuff you use originally, because you're likely going to get something wrong and you want to be able to make global changes very quickly. And you want to use that information to decide on the abstractions that you actually want. So you don't necessarily want developers to have to know every single ins and outs of Kubernetes, because it's kind of one of the foundations of science and society in general, that you want to factor out knowledge over multiple groups of people. So we kind of need to think about what we actually wanted. And this is very similar to what we had, except swap Kubernetes for this set of servers that are load balanced. So we didn't want to rewrite that world. We kept the same system, except instead of this manifest repository, which I'll talk more about, we had this chef repository, which no one dared to touch because we had no security on it. People could commit in there, and we weren't sure if it's going to work. It kind of failed in the middle of chefing, so it's not great. So we instead realized we need a lot of security if we're going to follow this model. And we're going to also have support for people to just push things directly into our dev environments, as shown in the flow above here. So that's kind of what we wanted to lock this down. And we want this to be completely self-service. We want to be easy to catch mistakes in this manifest repo, and error handling needs to be perfect. And every kind of developer knows Git, so a GitOps style pattern works very well as a starting point. So that's what we went with. And we started writing a tool called Shipcat, which is our kind of API abstraction on top of Kubernetes. It's now open source at Babylon Partners /Shipcat. You can go look at it. It's written in Rust. It does all kind of the security of it deals with a lot of the structures that you put inside your manifest, your API, and because of the language, we get a lot of safety from the actual parsing in there, to a point that's kind of ludicrous if you think about it, because not only are you parsing into type-safe structures, we're also telling it to throw away anything that doesn't, or ignore unknown structs or something like that. Basically, it lets you catch any type of spelling error that you get in there, which is something that goes against the normal API principles, like REST principles, that you should be lenient with what you accept, but strict about what you send out. We don't do that. We are strict with everything, so that we kind of develop this tool along with our manifest repository, so that we update this. We also update manifest to match it. And it gives extremely strong security thing on that repo. So this is our tool. It obviously fans out to Kubernetes with YAML generation. In a way, it's a little analogous to Helm. In fact, it leverages Helm at the moment for templating and deployment. But we didn't go down the route that Helm is doing with doing all the kind of validation inside Helm templates, because therein lies madness. So I want to talk a little bit about how our setup for this is. Basically, we have a single repository where we have all our services in a services folder and the one chart where everything goes through. So this is, here we have an example set up with two services, a blog and a web app. They have this master manifest, the shipcat.yaml. And then we have a region-wide overrides. So if you want this blog deployed in prod, maybe it needs some overrides. In this case, maybe you want to set some auto-scaling parameters. This allows you to do this. These files take all the same parameters as the manifest, but they are merged into it. And also we have this nice little global config at the top here, where you can merge in regional defaults, like things of where are all your external resources that you don't have on Kube. And if you are migrating to Kube, you will have those. So like this is backed by Vault for secrets. So where we can reach Vault is in that, based on the cluster. And we have all these commands basically to show how this kind of maps onto Helm. We have this concept of Shipcat values, which is going to be the completed thing that you normally post to Helm that you can only get back, I think, if you ask it directly. And but that's going to be the result of this three-way merge between the master manifest, your defaults from the region, and the override from the folder, like the prod YAML. Templating is done via Helm. It's analogous to Helm template, passing it into the base chart. And we also have a Shipcat apply function, which is going to be the idempotent version of Helm upgrade. But then we have our validation logic, which is basically every single thing, every single struct that we implement, that we allow people to use in their manifest, we have logic in there. And that does a lot. It does a lot of cross-referencing of these structures. For instance, if you expose an external HTTP port, you have to have a health check. That's common sense, but that's something we can enforce in there rather than splatter it all across our template logic. So here's one of the things we allow in the manifest. Pretty standard stuff. This is pure kube API. It's literally the limits and requests that you ask for on Kubernetes. But we add extra validation on top of that so that you can't mix up what requests and limits are. People do that. You cannot request more memory than our biggest node in our kube cluster, because you're just going to have scheduling errors. And also, we don't allow you to misspell like requests so that kube potentially rejects, or not rejects, but silently ignores that part, and you're scheduled without requests. So this is one of the parts where the kube API is really nice. We haven't had to do anything. A lot of the structures are just kube API. Some of the things are not. This is our configmap abstraction, because we found that effectively we had all these sets of config files that was essentially the same, and it was mounted into every single service. We had like New Relic configuration, this huge file that only changed 2 little things, like what service name is this, what environment is it running on. There's Python login configuration, also just needs like a service name. And there's like a templating engine screaming to get out in there. And if you try to actually do this with Helm, it's quite difficult, because Helm doesn't let you actually put external templates into your normal set of templates. So you got to do some kind of hackery with Bash where you pre-template them and pass them into Helm with --set, and you got to be extremely careful with how you sanitize that. So we just did all this logic in here. We put a templating engine in Shipcat, it's normal Jinja 2, and we've just passed it a very limited context, which we actually validate before you even get to merge into this repository. So these templates will be renderable. So we did all of these structures. We added them all into the manifest struct, and we started basically reconciling our clusters from these set of manifests. And I got to do this glorious commit where I deleted 23,000 lines of more or less handcrafted YAML. I think if I were to generate the YAML now again from the manifest, it would be pretty much like 100,000 lines of YAML just in a dev environment. So this would not have scaled, and this made me very happy, so I included it. Oh, yes, I have a little bit of a demo. I'm not sure if it's going to work. Does that work? Nope.
Do it on that one.
Sorry?
You'll need to do it on that one.
Okay. No, it doesn't work. Whatever. It wasn't even a demo. I'd recorded it in ASCII Cinema. Whatever. I'll post it. Can you? How do I get this back up? I think I closed it. I don't know.
Wow.
Yeah. Sorry, guys. Shouldn't have tried.
Mind that?
Yeah. Okay. I'll. Ooh.
No. Where are we? All right, we're back.
Okay.
And we're back.
You don't. Okay.
You try?
Let's try it. Whatever.
Nope.
You're on the Wi-Fi. No Wi-Fi.
Let's move on.
Yeah, whatever. There's still be a link. So this repo is public, and essentially this is just going through the example thing. It's deploying a setup like I just showed in here with minicube, and it takes about a minute. All you need to do is set up an external vault, and web app here uses a database, so we set up a sample one in Helm. So it's showing how to do it. I'll skip it for now. So let's talk about Helm. So we've followed the one chart to rule them all approach that was kind of popularized by Ticketmaster. They had a talk about it in December last year, where effectively the rationale is that it's a lot easier to just allow your Helm chart to account for all these different things rather than forking these 2,000 line YAML charts. So the natural corollary to that is that you end up with these super general templates where everything is templatable, and effectively, this ends up being quite brittle, right? Because you need to test every single path through this, and there's no real good way of doing that. You obviously can run it on all your applications, but Helm doesn't really have a good support for doing that. So this is kind of maddening. And also, like, look at this pattern here, where you have this templated YAML that you're passing YAML and putting it into putting it to a to YAML function, and then indenting it a particular thing. This is a Helm pattern, and I think it also sometimes relies on that some of these can be null, and therefore this line doesn't exist, and then having this means it's equivalent to null. So it's kind of crazy, because you can see what this is. Like, if this was an actual in code, this is, you're assigning a struct to another struct. Like, this is a really convoluted form of assignment, and I don't know how we ended up with this particular pattern. Like, I feel like Helm should have been providing a better API for this rather than going down this template madness. But while I'm ranting, commands and resources. Can anyone tell me why the indent is different in those two? Silence. Okay, it's because the resources is a struct and command is a vector, and vectors are naturally aligned at the same level as the parent struct. So you can't even like read this. Like, you have to take into account what's the type you're passing into this. So it's crazy. So one of the things we kind of thought about is, can we get away from Helm? Because what does it actually provide for us? Obviously templating, which is an industry practice, if nothing else. And also, it's not even the most painful part of Helm, because it's just a client-side thing. And Tiller is what is kind of we have more issues with. Rollbacks is a thing that we used and was quite useful, but now that we're in this GitOps-style paradigm, rolling back is kind of just a git back out. So we don't really need this anymore. Grouping resources together and kind of allowing Helm to garbage collect the old stuff that you post up to Kube. It did this really well, but also not something that's really needed anymore, because if you do kubectl apply with --prune, which is a fully stable command in 1.10, I believe, it's just going to prune out everything that's not related to the label that you give it. And if you label your thing judiciously, then this should all be fine. Diffs, on the other hand, that's the one thing we've not been able to really replace. Helm has Helm diff, and that's very useful. Kube does not really have the same type of functionality. You can ask Kube to get -o YAML, and it gives you a different YAML to what you posted, very helpful. And so you need to do some massaging to it. I know Weaveworks has a particular plugin to do this, but it doesn't do it exactly well, unfortunately. So if anyone knows this, please talk to me afterwards. And then the final one is the more kind of more philosophical approach here, where do you want Helm to be your single source of truth? Particularly because you now also have two other sources of truth to contest with. You have your master manifest repository, you have the Helm state, and then you have your etcd state that Kube directly uses. And even that last state can be out of sync with Kube when your node goes haywire. So there's translation errors between every single one of these sources. And we know for a fact that Helm itself does have some issues with getting things correctly applied. We had environment variables that linger over sometimes when deployments fail, and we've not been able to get to the bottom of it. But beyond that, we've had, we'll bring it back to a positive note. We've had good success with basically following this approach of having everything in manifests. Even with 200 services in there, and like, I don't know how many Kube clusters we have now, 20, that are all automatically reconciled when we merge this repo, like 50 to 100 times a day. The deployment times are still mostly limited by how long it takes for your service to roll out, and that's basically the boot time times number of replicas. So we're pretty happy with this. It's not like this fancy distributed thing with operators running inside the cluster, but it does work really well, and for now, it's a really good way of starting out. So I think that's where I'm going to stop it for Shipcat. Brad, would you like to carry on?
So I can attest, having joined Babylon almost 3 months ago, I mean, I've been there forever, right? Is that this path is very, very quick for new developers into the teams. It's very, very quick for anybody who's got to operate services. It's super expressive when you can look at a kind of higher level view of everything that is only essential to your service. It really distills down the amount that you have, the kind of control plane within that. So it's not the only pattern, the only tool that we have in this pattern. We also have developed a tool called Steamroller, which sits above Tarmac. Tarmac is JetStack. They're effectively a kind of a COPS analog to installing clusters on any cloud provider. It really kind of catches as much as possible for us, and it lets us get our clusters into a known state. It's an expression of the entire cluster state with services and persistence, et cetera, on that once we've brought the cluster up. So it's another tool, a kind of force multiplier for getting us into something very, very quickly so we can kind of keep the customers moving through the door. So I think that probably does break code of conduct. So where are we kind of as we go forward, right? Like, this is approaching cloud scale things as we get bigger and bigger and bigger. We have to continue to create tooling and habits around this that are the same amount of expression. We're doubling the team instantly. We're kind of 10xing the business, obviously, and really that should be 10,000 times the YAML, because even though we're abstracting some of that away, there's still plenty there, and our services, as we've mentioned, we're in the hundreds of microservices operating in a cluster, so there's a lot to contend with, and 150 lines of one manifest to express all of that is pretty magical. Obviously, we need to give big thanks to our team, some of which are over on the tables back there. Super smart group of people. I'm really honored to get to look after them now that I've joined the team. That's it.